Hello, everyone. Good morning. This is Pritesh here. I'll be the host for you for today's session. And thank you so much for joining on time. And we will be starting in another 5 minutes. We will just wait for some more people to join and then we'll quickly start. Okay. In the meanwhile, some basic rules. If you have any questions, any doubts that you want to ask, feel free to drop your questions in the Q&A sections. Right. We will answer each and every question when there is time. Okay. In the meanwhile, if everyone can help me understand where they are connecting from, your city or state, whatever is comfortable, you can just write it in the Q&A box or the chat box if available. Okay, we have some joining in from Cyprus. Then we have people joining in from Delhi, Varanasi, Agra. Wow, great. Okay, then we are good to go. And thank you again for connecting on time. I will start with introducing UniKaksha to you, and then I will be introducing the mentor to you, and then we can take it over from there. Okay. So basically, about UniKaksha, we are an online education providing platform that helps students and working professionals upskill themselves in their tech career with the help of top mentors and industry relevant curriculum. So far, we have had positive impact in careers of 5,000 students. And today with this Guru class, we hope to help you in the same manner, right? So basically, UniKaksha is an upskillment platform that is helping, professionals or students like you to upskill themselves. Okay. And today's session is going to be taken by our expert mentor, Swati Yadav, right? And a bit of introduction about Swati Yadav. Swati Yadav started her career as a full stack developer in new gen software technologies and dealt with fintech and banking processes. She gained experience starting up her own project and implementing large scale projects, right? And she was able to engage multiple foreign clients and higher management during her tenure at Newgen. And also, she has experience in various technologies like Python, Python libraries, data science, Python, Mon full stack, and a lot more. Okay. And with that, I would like to introduce the mentor to you, Swati Yadav. Swati, if you can just say hi.
Hi, good morning, everyone.
Yeah. And before she takes it forward, I would also like to give you a brief about the topic. So today's topic is automated driving with data science and machine learning, right? As we all know, we are moving towards, automation in driving. A lot of things have already come up, right? And we will be understanding how data science and machine learning helps or it helps to create an automated driving experience. Over to you, Swati.
Yes, hi, everyone. So, welcome on a Saturday morning. So, we have our session today on automated driving with data science and machine learning. It's an introductory session to give you a understanding about how data science is basically changing the world around us. So there is a little doubt nowadays about the growing importance of data science, big data, and machine learning, especially in the automotive industry as well. So we all are aware of autonomous cars, right? So autonomous cars, they are a trending topic in all circles of interest. Yes. So both for experts in the field and, regular people who just want to upgrade their cars as well. So thanks to the advancements in technology, automakers, they've gained access to numerous autonomous features, enabling them to, kind of radically transform automobiles into vehicles connected 24/7 to the internet. So basically, cars are not just mere means of transportation now and in the future maybe, but can also entertain us They, as of now, you can make you can make calls, you can shop, pay bills, and even save lives. The innovation in the automotive industry is no longer driven by manufacturing, but by data science, right? So the data gathered during the process of manufacturing and driving can now be used to improve all processes related to vehicles and to make driverless cars a reality. In today's session, we are going to dig deeper into these aspects related to data science. We are going to talk about the agenda is for to see what is the data science, how data science work in the automated driving. Okay, so we are going to talk all about that, look closely at how all of this data can be used to improve the production, finance, product development, and customer analytics in the automated industry. So as well as promote the concept of smart cities and obviously smart lives, right? So now how does AI, the very first thing which comes to me is how does AI, it works in autonomous vehicles, or what is the use, data science, AI, ML, they all are interrelated, right? So now AI, it has become a popular word, tech industry. Does it actually work in autonomous vehicles? And if yes, then how? Now, to understand this, we have to look through, the viewpoint of a human, right? So to understand the AI better, first we need to understand the human viewpoint of driving a vehicle, right? With the use of sensory functions such as, vision, you see, right, when you drive, the sound, to watch the road, and the other vehicles on the road as well. So when we halt at a red signal or wait for a pedestrian to cross the road, we are using our memory to make these quick decisions over there. And the years of driving practice leads us to look for little things, yes, that we often, we face often on the roads. So it could be a nice route to the home that might avoid the bumps in the road. We are building autonomous vehicles that drive themselves, but we want them to drive as human drivers do, right? We cannot just leave them on the road, go do whatever you want to do. No, they have to be smart enough to think like a human, to take decisions like a human, right? So that means we need to equip these vehicles with the sensory, cognitive functions like memory, logical thinking, decision making, and learning, and administrative capabilities that humans use to drive vehicles on the roads. The automotive industry is continuously developing to produce this exactly over the last few years. If you talk about robots as well. So an automated car is what? It's kind of like a robot, functions like a human, right? So it's a robot. So the robotics industry, this whole industry, it's actually working on this, that how they can mimic human behavior, right? So that is, how we are going to talk about it. And if you know about, in 2009, Google launched its self-driving car project in 2009. Now, within 18 months, sorry, they developed a system that could maneuver through some of California's trickiest roads without human interference. Then another one came in, which is Tesla. They joined the race by building automating features into the vehicles, such as, one is your blind spot detection, auto braking system, lane departure warnings. Uber and Lyft, they have also began investing heavily in making ride sharing an autonomous task. So soon after, all major automakers, they are following the same suit, as well as hundreds of startups have come up, sprouting up to offer improved autonomous features to help these giants in their endeavors. If you know about Intel, so Intel and there is a strategy analytics estimate that the global economy will see a $7 trillion boost from this arising industry. Okay, and it's going by 2045. So it's a long run, but yes, it's something which is going to have a deeper impact technologically and yes, to our lives as well, right? So when we talk about how humans are replaced, so to simulate a human brain and its cognitive networks, a basic self-driving car must be equipped with, they should be equipped with number one, highly detailed maps. They should have that knowledge, highly detailed maps of the street features. They should also be available of the sign, the curves, the lights, etc. Every turn, every nook and corner, they should be aware of. The second most important things comes as sensors. Sensors such as cameras, very, the common one. The LiDAR, which is LiDAR, which is similar to radar, but uses light to create pulses instead of radio waves. Okay. So short distance 3D layouts of its surrounding in real time. So sensors like cameras and LiDAR, vehicle to vehicle cloud communication. There should be a cloud communication. How come, to have that? Because now the car is driving itself. So I cannot say we can give them eyes, but we can give them sensors, right? So cloud communication, sensory inputs into the vehicle's machine learning algorithm needs to be implemented to predict outcomes which are based on an enormous volume of data. So once the car is on the road, I'm saying, there will be enormous amount of data that it needs to handle to drive safely. Okay. And in order to plan and act. Now, the first three features which I said, like the detailed map of street features, sensors, like for your LiDAR and cameras, and vehicle-to-vehicle cloud communication, they are already commercially available in many existing models, the newer cars that are coming, right? So sensors, they provide detailed 3D maps of the surrounding environment. I hope we've seen that, sensors. Do you know when you're turning your car back, what's there, at how many distance that is there? That are all sensors. Okay. Now it like provides you a detailed 3D map of the surrounding, about the signs. They identify the pedestrians, assist in parking spaces, and to name a few, these are, the many things that are available. Altimeters, accelerometers, they provide more accurate positioning than GPS alone, right? And the more trips a car makes, the data is collected to update its knowledge of the map and the environment as well. So it is estimated that a single self-driving car could collect up to 1 GB of data, okay, of data per second. Now think about the number of sensors and the instantaneous and constant need to transmit information which is required there. So, this is how it has to be planned so that it can actually replace a whole human, driving the car. There are going to be cons as well if there are pros, but then to think it from a technology wise, it's kind of a new adventure to, get on, right? Now, the next thing which is there, you have a little poll coming up just to check how engaged you guys are. So could I have a poll up?
Okay, the poll is active and I would request everyone to participate in that. It is just to understand, your understanding of the concepts, and it will give us a better clarity in terms of how we can take this forward. So everyone quickly, you can answer the poll. Okay, I'll be closing the poll.
That's great. I see quite a good number of you have given the correct answer, which was all. So, maps of street features, LiDAR, and cloud communication, all three contribute to that. Okay. Now, moving on to the next part, which is to talk about the body and the brain over here for the, automated driving. Now, data scientists, they are the pioneers, they are the pioneers behind perfecting the brain of the beast, which is your driverless cars. Now, we must somehow figure out how to develop algorithms that's going to master things like perception, localization, prediction and planning, and control. So how do we distinguish the difference between a stray shopping cart and a person in a wheelchair? That is something that we have to be equipped with. Not we, the cars, they have to be equipped with. How do we know which direction the person on the bicycle will turn to gauge that? And how do we differentiate between normal and abnormal situations? And when do we decide to break the law in order to save a life? Right? So these algorithms, they need to be developed, they need to be mastered. If they are already in place, they need to be mastered. Perception, localization, prediction, planning, and control. So perception, it basically, merges several different sensors to know where the road is. It merges several different sensors to know where the road is and what is the state. I mean, like type, position, speed of each obstacle in the way. The second which comes is your localization. It uses very specific maps and sensors to understand where the car is in the environment at centimeter level. Then comes your prediction and planning. So prediction, it allows the car to anticipate the behavior of objects in it, surrounding, to anticipate the behavior. Okay. Planning is to use the knowledge of the car's position and obstacles to plan routes to a destination. That is your planning. So you need to plan ahead, right? Okay, I have to go from A to B. Now, which route to take, and how to go about it. That is all your planning phase. Okay, the application of the law is coded here and the algorithm defined waypoints. Control is, the control is to develop algorithm to follow the waypoints which are there effectively, so that you are, the car is driving safely without any casualties, anything that goes bad over there. That is a control. So using machine learning and your deep learning algorithms and AI, it really is an iterative process where the cycle of collecting data to interpreting the data to training the algorithm is endless. It's an iterative process because you cannot control the environment, right? You cannot control the environment in which you are. Today, you go out of your house from, let's say you want to go to office, you go out, get into your car. Do you see the same people walking the street at that particular point of time? No, it's changing, it's varying, right? It's not constant, it's dynamic. So it's an iterative process. So when you are teaching a machine that, you have to go, this is your time, you have to leave this place and be at there. So now you have to make your machine smart in such a way that it can handle any kind of pressure that comes in, any kind of obstacle, because things, they do not remain same. You can teach a machine from point A to B. If the environment is same, that would be this, very simplest task to do. But our environment is changes constantly. Today you have some work on the street. There are laborers who are working on the street. Tomorrow you might not have it. Tomorrow it's a very brand new, road that you have. Again, that's a change. So that is, it's an iterative process where the cycle of collecting data to interpret the data to training the algorithm is endless. And the more your models, they are trained, the more smarter they become. They are better. The training is an endless process in your data science, in your AIs. Okay. In other words, we must be able to make the real, or to take real life driving experiences, turn them into programmable information and train our models to continuously and self-sufficiently improve its understanding of the real world in order to make informed decisions, correct decisions. Okay. So that is about your 4 phases or 5 phases which are there. Now talking about perception and localization. Just give me a moment. So perception and localization, right? So for a machine to see, it takes two steps. There are two steps involved for any machine to see. Anyone who's already have a little bit knowledge of data science, you might be aware of two things. One is image classification and another one is image localization. Okay, let me take you to, there were a few things that we are talking, which is, the phases that we talked about. Perception, localization. So currently we are on this phase that we are discussing. So for any machine to see, there are two steps which involves image classification and image localization. Okay. So image classification, it is like, is determining what it is seeing, what you're seeing. Okay, that is your image classification. Localization means is knowing where it is seeing the object. Image classification is nothing, it's just only what you are seeing. Localization is where you are seeing that object. And now to perform these two steps, we need to use something which is called as CNN. It's part of neural networks in deep learning, which is convolutional neural network. Convolutional neural network. Now, training the CNN will allow it to perform, operations on images in order to classify them and to locate them. Okay. Now, the problem which comes with CNN is that it can only pick up a single portion of an image at a time. Fine. The problem which arises with CNN is it can only take, so here, it can only take a single portion of the image at a time to perform classification on. So what if there are multiple things in one images that you need to capture? Okay. So we write something which is called a sliding window algorithm. And this sliding window algorithm, it allows to slide across the image to take in all portions of it. Then each portion is run through your CNN to see if it corresponds to any possible object. For anything other than a person or a detectable object, the CNN will return true, and otherwise it gives you a false over there. So there is a one more concept of algorithm, which is your sliding window, which comes into play. The next thing which comes in, which is, what if the object is, it's much bigger. It's much bigger, or you could say smaller than the image itself. Okay. We can break the whole image down into the grids that we see and run the entire image through CNN. So the algorithm used for this is called YOLO. YOLO means you only look once. It's not you only live once, it's you only look once. Now the resulting output is a class probability map that we see, which spits out the probabilities for each grid cell being a specific object. Okay. So YOLO is, you can say it's an enhancement of sliding window, since it returns the specifications of, or predictions of small portions of the entire image instead of multiple run-throughs through that image. That's a difference. So it's a YOLO algorithm. Now, given that we know whether an object is present in each grid, how do we know where it is within the grid? Okay, now how to determine which object is where in the grid? There comes another technique which is called as, Kalman filters. Okay. So we use a technique called Kalman filters, and to find their position with the highest possible accuracy. we can use a non-max suppression algorithm. Non-max suppression algorithm, which comes in, okay, to train the CNN then. So we compare the results that we generate from the CNN for each grid to the actual grid which is there. However, we also want to consider if parts of the same object is in multiple grids, and we don't want to count the same object multiple times. So there, the non-max suppression is a way for us to make sure that our algorithm, it detects each object only once. So each object will be detected only once. Okay. What non-max suppression does is to clean up multiple detections of one object. We define there is a cost function. Okay. There is a cost function as the area of suppression. So here what we have is, we define there is a cost function as the area of intersection divided by area of union of two grids that we see. Okay. So the closer the function is to 1, the closer the function is to 1, the better our prediction comes out to be. Okay. So first we take the grid with the highest IOU, which is area of overlap by the area of union. Okay. Or you could say the most confident detection within this grid. Then for the remaining grids that overlap and has high IO, we suppress them so they are not detected for the same object. Okay. So there is how it works that you see. So this is about your perception and localization. You have a poll coming up now. So let's do a quick poll.
Okay, the poll is live. Quickly, guys, quickly, everyone, just answer it. Okay, I'll end the poll.
Okay. So the answer to this was CNN. Okay. You will see what is RNN, but it was not both. But it's good that you guys have attempted that. Now moving forward to something else, the rest phases of it, which was prediction, planning, and control. So given, perception and localization that we've seen, cars can now predict the behavior of every object. Okay, so it could be a vehicle, a human, or an object in their surroundings. So they can anticipate how the object will move and in which direction, at what speed, what trajectory they will follow. So what is commonly used for this is your RNN, recurrent neural network. So where RNN can learn from past behavior and forecast the future. Okay. So that is how it works here in RNN. Simple thing is that it basically learns from the past behavior and then it tries to predict the future. So recurrent neural network, so we have two kinds of data flow over here is forward in layers and in time propagation. Okay. So stack conversion, it operates using your back propagation. So to minimize errors by replacing human fine tuning with an algorithm that is, that implements the chain rules of calculus. And to train our model to essentially clone human behavior, we use something called as behavioral cloning, okay, to capture human subcognitive skills and reproduce them in a computer program in computer vision. So given the data which is collected, the RNN, it uses back propagation algorithm to reduce error and to update the parameters. There is a forward propagation as well. Forward and back propagation, both of them are there. Okay. So planning is the route to follow or, to generate trajectory, which involves search algorithms. So there are search algorithms such as A*, lattice planning, reinforcement learning, and A star algorithm is one of the best technique which is used in path finding. A star. Okay, and graph traversal as well. The algorithm works by finding there is something you might have done in mathematics earlier, which is called Euclidean distance. So this algorithm, it works, by finding the Euclidean distance between each obstacle, and it generates the shortest path between them, okay, between the starting and ending point. The next is your lattice planning. So this is how lattice planning, it basically looks like. It's demonstrated here. It's based on finally, after that comes your, the last step is to control engineers. So they use the trajectory which is generated in the planning step to change accordingly the steering, acceleration, and brakes of the car. So the most common method is PID control, but there are a few others like there is something which is called a linear quadratic regulator, LQR, model predictive control, MPC, but that is something, quite far advanced over here. So these are the phases which helps you, in the concept of self-driving cars. We all know that, when we come to the, because we have now reached to kind of the end of our, discussion on this, how data science helps basically. So autonomous vehicles, they use advanced machine vision, vision to react and drive on various roads. So they are constantly measuring, and analyzing the environment around it, making precise and rational decisions which are based on its reading, eventually which results in the safest possible maneuver. There is something which is called as vehicle trajectory analysis, and it's a process of attempting to characterize the vehicle's trajectory, which includes what? It includes the velocity and acceleration of the vehicle and is relative to the road surface. Okay. So as well as the angles and velocity of its parts. The computation and analysis process is affected by many other factors like the magnetic field lines, electronic infrastructure of the vehicle, the path it takes on its way to the destination, as well as how the wind, the natural wind I'm talking about, it affects the path. So autonomous vehicles are the future of transportation, yes, and they are reducing congestion, decreasing environmental impact, and improving safety. They are replacing human drivers, yes, and significantly they reduce the fuel consumption. So, the Google Vice President for Automotive Partnership, which is Beryl Lawrence, he stated that driving is now fun and convenient, and called autonomous cars a step forward in transportation as we know it. According to him, the technological breakthroughs enabled by new approach to transportation would allow humans to eliminate the necessity for driving in urban areas. Nevertheless, several representatives of the self-driving car industry and universities, they cautioned against taking their products and services lightly. So like you could say, but the question is, how soon again the human drivers, they can be replaced, right? How soon can we be replaced? So based on the work that is ongoing on, and with the patterns of human traffic fatalities, the paper, it states that reducing the mortality rate of human-driven vehicles may be a worthwhile goal over here. Okay, so it's a lot that can be done. The next that I just want to talk about, it's a very small thing, which is AI perception action cycle in autonomous vehicles. So a constant loop, which is called as perception action cycle, is formed when the autonomous vehicle, it produces data from its surrounding environment. Let me write it down for you guys. So there is something which is AI perception action cycle. AI perception action cycle in autonomous vehicles, and this perception action cycle is formed when this perception action cycle is formed when the autonomous vehicle, it produces data from its surrounding environment and feed it into the intelligent agent. who makes the decision and allows the autonomous vehicle to do specific operations in that same environment. Okay. So the whole process again is divided into three components, which is the three components. The first is in-vehicle data collection and communication system. The second which comes is autonomous driving platform. And the third which is there, it's called AI-based functions in autonomous vehicles. So there are three components to it. Now, in talking about the first component, in autonomous vehicles, there are numerous sensors, radars and cameras that are fitted, which are to generate, you could say massive amounts of environmental data. So all of these, they create the digital sensorium, by which the autonomous vehicles can observe, discover and feel the road, infrastructure and other vehicles out there. So this data is then processed with a supercomputer, and data communication systems are used to securely communicate valuable information to the autonomous driving cloud platform, which is there. Okay. So the autonomous vehicle first reaches the driving context and the particular driving circumstances to the automation driving platform. Then comes your autonomous driving platform, which is the second component over here. The autonomous driving platform in the cloud, it contains an intelligent agent, which makes use of AI algorithms to make meaningful decisions. So that abundance of data of the previous driving experiences will help the intelligent agent to take decisions for inputs from the autonomous vehicles. The vehicles are now knows exactly what to do in this driving environment or, particularly that driving situation. The third component, which is your AI-based functions in autonomous vehicles, is now based on the intelligent agent decision. The vehicle is going to detect the object on the road, manage the traffic without the human intervention, and goes to the destination safely. Okay, so these vehicles, they are outfitted with AI-based functional systems, such as, voice or speech recognition, signal controls, eye tracking, and other systems to monitor the driving, virtual assistance, mapping, and safety systems. These functions, they work on the decisions which are provided by the intelligent agent in the autonomous driving platforms. Okay, they have built to provide great user experience for customers and keep them safe on the roads. The driving experience generated from every ride is recorded. Every ride is recorded and it's stored in the database to help the intelligent agent to help that particular vehicle make much more accurate decisions in the future. Okay, so there are three components to it. So I hope, AI, especially neural network and deep learning, it have become an absolute necessity to make these autonomous vehicles function properly and safely. So AI is driving the way for the launch of next, level autonomous vehicles, where there will be necessarily, not necessarily any control for the steering, accelerator, or brakes as well. So I think that is how that is how AI is changing. The innovation that has come up is changing the modern car industry now. And, in the future, will be riding I think those only. Yes. So now this brings us to the end of a particular session. Moving on to Pritesh now. If you guys have any questions, anything regarding that you want to put up, please put it up in your Q&A.
Thank you, Swati, for this amazing session. I believe that everyone attending the session has understood the things very clearly. And I know DS and AI is a very large topic to cover in a short span like this. But I believe that Swati has very skillfully covered all the necessary technologies or topics that are required for this particular session. And with that, first, I would like to understand what is your views on this session, and if everyone can use the Q&A section to help us understand what is your view on this session, it will be very helpful. Apart from that, if you have any questions, any clarity that you require, you can also post it in the Q&A section. We'll be answering that questions right now. So we'll take a 5 minutes time and answer all the questions that are required. Yeah, please go ahead and use the Q&A section to ask queries. Okay, so now I will be launching a poll again for data science and the program that we have. And I'll request everyone who is interested to learn more about data science and machine learning, AI, to fill in this poll so that we have our representatives, counselors reaching out to you and give you clarity more about the program. And I will also brief you in terms of how the program is, what the program, how you can benefit from this program and what's the context of the program. All right. So first, I would request everyone to go ahead and fill the poll, and then I'll give you a short brief in terms of how the program works and how UniKaksha actually helps people or learners like you to excel in data science and machine learning. Okay, I have a question meanwhile. If Swati, you can take this up. How data science will help me as I am from system engineering background.
Okay, yes, hi. Just a moment. Okay, so you are particularly from a different stream and you want to get started with data science, which is again a very good thing, as we all know that how the technological advancements are happening these days. So data science is obviously something that is here to stay, is here not just to stay, I would say, something that is always going to be a promising future, So data science, it can add value to any business who can use their data well. So from statistics to insights across workflows, and hiring new candidates, data science is used everywhere. So I don't think that even if you are from some other background, from some other domain, and you cannot get started with data science. So the only thing is, once you have the thing, that you want to get into this and you want to be a system, data science engineer, data scientist, or a data engineer, and once you start your journey on it, you are the transition will be smooth, as you already are aware of much of the technological things that are there. So the transition will be smooth for you, and it's all also going to be a promising thing for your future as well.
Wonderful. Thank you, Swati. There's another question. The class was interesting. Please, I need to get enrolled into your training. I was not. Okay, so I will make sure that someone would reach out to you shortly, right, and get your query solved. Okay, and for the folks who are asking questions like how do I get enrolled and what is the procedure, of course, what we've done is we've taken a note of people who are looking forward for the program, and we will ask our counselors to connect shortly with you. And speaking about the course, I'll just give you a bit of background in terms of how the course works. So basically, our data science program is an intensive program where we cover all the latest technologies or all the latest developments that have been in this industry and that are currently trending, and whatever is required for you to become a successful data scientist. Okay, now how do we do that? We do it through a 4 months program. All right, and the key USP of this 4 months program is that we have folks like Swati and other folks who have been in this industry, who have good amount of experience of implementing projects, working on large scale projects. These are the people who are going to train you. Right. So you have to understand that, when you get trained from experienced folks, the training is much more fruitful. Secondly, our program is all live classes. Right. So all our classes will be live classes. You will be able to ask queries, questions, and get your doubts resolved then and there. Thirdly, this is a certified program, so you get certification after you complete this program as well. And we are an end-to-end program, right? So when I say end-to-end program, it means that we start with upskillment, right? But after that, we venture into resume building also. We help you with mock interviews also, and finally lining up interviews for you as well, right? So it's not like after upskillment, we leave it on yourself to find a job for yourself. No, we take that guarantee on ourselves that we will be providing you with suitable jobs as well, right? And in detail about the program is something that the counselors will connect with you and give you an idea about that. And that's pretty much about it. And any other questions, anything that you want to ask, you can use the Q&A as well. Perfect, perfect. So I think with that, we will end this session. Thank you so much once again for connecting on a Saturday morning. I know, you can do a lot of other things on a Saturday morning, but you choose to upskill and learn something new. And thank you for that. And we will connect with you shortly again with the next Guru class. Thank you so much.